Hello, I'm Matthew Thompson. I am a research associate at the University of Bath working on the DM40 projects, which is a data management project for the TeddyNet collection of projects at different universities, where universities have lots of sensor readings from smart devices collecting data about the energy usage of homes. And so the DM40 project is about finding ways to add metadata for all these different sensor readings which have been compiled by different universities so that we can query across these data readings and get a kind of picture of the overall energy usage from different sources. And I'm working on building a tool called MetaMaker, which is used to add metadata to files, CSV files ideally, that describe lots and lots of sensor readings from home appliances. And so the way that you use it is you can either upload a local CSV file. At the moment it supports CSV, but we want to support other formats such as HDF in the future. And also, at the moment we are uploading local files, but we would like to have a way to add a URL of a remote file as well, which the system will download and analyze the file from. And so you can type in the name of the dataset. Let's call ours test dataset, and a description. And you can add some file metadata, and this is metadata that describes the content of the file as a whole. So if our file contained only power readings, we'd narrow down the kind of category of metadata that we're looking for from category and then select power from the subcategory. And you can add multiple types of metadata to tag your file with. Moving on to the individual columns of the CSV file, each column is represented by a tab here. And so this is automatically read from the CSV file that we just uploaded. And it should infer the data type of each column as well, which in JavaScript is just a string or a number. But you can change this if you like. And so we have a timestamp here. Let's add some metadata saying that it is a timestamp. So we find category, subcategory, timestamp. And again, we can add multiple metadata tags to each column of the CSV file. Let's add some information about our house. So it is a location, subcategory house. A room is also a location. Room. Appliance. And that's also a location. Sensor is a location. And value, finally, is a kind of value, of the actual value of the sensor reading. And so all of these types of metadata that we've now tagged each column with maps to something in an ontology. It's not just a kind of arbitrary label that we've chosen. We are using an ontology called the SEAS ontology, which was created by a group called the Smart Energy Aware Systems group, which is in France. And it actually incorporates other ontologies such as the semantic sensor network ontology, as it says down here at the bottom. So it's very useful for describing different types of sensor readings, different locations of the sensors in a home, etc. So that's what our metadata maps to. Also, the approach that we're taking is, instead of looking at every single reading in the CSV file and transferring that to a semantic web triple or an RDF triple, we are just describing each column of the CSV file using our semantic web RDF triple. And the reason for using RDF triples is you can read it into a triple store, which is like a graph database, and it allows a lot of flexibility with the querying. With traditional databases such as MySQL, In order to query the database, you have to know the structure of how it's stored. But to query a triple store graph database, you just have to know the ontology you're using, in this case the C's ontology. So we're describing the actual structure of the CSV file itself using this CSV ontology from the NTNU University in Norway. And this just allows us to describe which each column of the CSV file represents. And so once you've added your metadata to the file, you can click to download a turtle file. Turtle is a representation of RDF, which you can use to add your metadata to some kind of triple store. So if we download that, you could also click this Create Metadata button, and this will upload the turtle file and all the triples to a service that we're running, which is our own triple store, which people can query to get the metadata back out. And so if we look at what's actually inside this turtle file, we can see we're using this CSV ontology to describe the columns, and a value, for example, maps to a semantic sensor network. At the moment we're using this DM4T placeholder to generate the triples, but this is going to be replaced with some information from the C's ontology. So that's where we are at with this MetaMaker tool at the moment. So here we have the other side of the interface. This is the part of the interface that we would use to query the semantic data that we've created, the metadata we've created for our data sets. And this front end is something I'm working on at the moment. It isn't actually functional yet, but I'm just going to explain what I want it to do so you can get an idea of the functionality of what we're trying to create here. So once you've uploaded the triples you created with the MetaMaker tool, it will be available as a data set. The metadata will be available on our Sparkle endpoint, and you can select the data sets corresponding to the sensor readings from one of the TeddyNet projects. And then to filter down the specific data you're looking for in these data sets, you'd select the same metadata categories that we used in the MetaMaker tool just now. So say you're looking for only gas readings from a certain range of data sets. You'd describe the kind of category, the metadata category there, and you can add other categories. So you'd want a kind of a start time and an end time. For this start time, we need a third box here which specifies the actual start time, and again for the end time. And what other metadata could we have? We could have in a certain home, for example. So we have this kind of way of filtering the information from these data sets to specify what our query is. So it could be, yes, only gas readings in May 2014, for example. And so once we've added these are converted into RDF triples and translated into a Sparkle query, such as the one down here. And then this is used as a query to our Sparkle endpoint. When you click Send Query, it will send this query to the Sparkle endpoint, and that will look at the CSV metadata that we've added previously, and it will say which CSV file contains the information we want, and what columns in that file contain the information we want. And the columns from that file will be streamed into this interface, and the specific reading values that we want will be filtered out. And the reason we chose this CSV streaming approach is that we actually previously described all of the readings before in semantic web triples and stored them in a triple store. But that came down, that ended up being billions of triples, and it took a long time to query with Sparkle queries. So we are using this more efficient CSV streaming approach where we're just streaming in the data we want. And another advantage of this approach is the CSV files that we're streaming in don't even need to be hosted by our service. They could be a CSV file that's contained in some kind of repository that's maintained by another university. So thank you for watching this video. I hope it's been informative and useful.